this video, we're going to be taking a look at the structured query language, in particular, how you use it in Microsoft Access. And this is quite a powerful tool that lets us ask questions or query our database. It can join together multiple tables and allow us to sort of cross-reference data and create quite complex answers to the questions we have. We'll also be taking a look at the query design tool in Microsoft Access. This is sort of a visual way to create these queries with a graphical interface instead of writing them by hand. But before you start using the query design tool, do watch the first part of this video and make sure you have a good understanding of the structured query language, because it is good to be able to read those kinds of statements and write them by hand before you start using a tool to generate them. But before we get into all that, there are a few required readings for the week. As usual, there's going to be an SQL and queries tutorial slides. These are those type of PowerPoint slides you've seen before that sort of go in depth into the subject, whereas this video will be more of a practical example. There's also the past video tutorials on Microsoft Access, including Microsoft Access going from an ERD to a database, which you should make sure that you watch before watching this. You will need a little bit of a base understanding of Microsoft Access before we start getting into the structured query language. And without further ado, let's get started by going over what SQL is. So Microsoft Access isn't just a dumb database. It's not just an Excel sheet that you just dump data into. It also provides a lot of tools for analyzing that data and running what we call queries on the data. And one of the ways we can do that is with something called SQL or SQL. It could be pronounced either way. Usually in English-speaking countries, it's pronounced SQL, and in more international areas, it's pronounced SQL. And that stands for Structured Query Language. And this is a language that we use to basically communicate with the database. We can use it to ask it questions, and we can also use it to instruct it to do things like update records, delete records, remove records, things like that. SQL can be divided into a few categories or sublanguages. First, we have DML, the data manipulation language. That's going to be basically how we can ask questions of the database, ask it to find certain records that meet our criteria. It's how we can insert new records, update records, and delete records. There's also the data description language, which allows us to basically alter the tables and the structure of the database. There's the data control language, which allows us to set up access control policies, who can access what tables. And there's transaction control language. This is a little bit more of an advanced database topic, but it allows you to control what we call transactions. Don't worry if you don't know about that. That's something that would be covered in a more advanced database course. For this course, what we need to concentrate on is the data manipulation language. And that's going to focus mostly on 4 different commands: select, insert, update, and delete. So before we get too far into SQL, there is something that we should note for anyone that has some past experience with SQL. Maybe you've experienced using MySQL, SQL Server, or some of those other enterprise-y database management systems. And the big thing there is that Access SQL uses a slightly different standard than those. Those would be using something called ANSI or ANSI SQL, while Microsoft has their own take on it. So they're mostly the same. There's a few small changes, mostly in the wildcard used for strings. But if you're familiar with the standard ANSI SQL, I will be posting a link under the supplementary material on OWL that will describe the differences between the two. If you've never used SQL before, this is your first time learning about it, then that's great. You don't have to worry about that because I'll be covering everything in Microsoft Access SQL. The first topic we're going to be talking about today, the first part of this video, is going to be on the select statement. So the syntax of the select statement looks like what we have up on the screen here, and it has 3 parts. The select part, which will say what we're selecting, the from part, where we're selecting it from, and the where part, which lets us set certain criteria. So we're going to be giving an example of that in actual Microsoft Access, but keep this format in mind. I'm going to switch to the desktop now. So now you should see Microsoft Access up on the screen, and the database we're going to be using is that doctor's office example from previous weeks, except I made a few changes to it. Let's take a look at those changes. First, we'll take a look at the relationships. The biggest change is we now have this last checkup table here. And what this does is it's going to store basically the results of the patient's last checkup with the doctor. A few different vitals, like their beats per minute, their oxygen saturation, their weight, height, and any notes from the doctor. It's set up as a one-to-one relationship, so this table is always going to store the latest data, the last checkup for the patient. So each patient has exactly one record in last checkup, and each record in last checkup maps exactly to one patient. So this is a one-to-one relationship. Quick reminder of what we already have in this database is we have a patient table that lists information about the patient. We have a medication table that lists medications the patient are on. They can have multiple medications in this table, but each medication is going to jump or relate back to a single patient. We also have a doctor's table, and the doctor can have multiple patients, and each patient has a single doctor. So we don't have to worry about these other tables for this tutorial. These were used in some of those past tutorials. So the other thing we should look at is I've made a few changes to these tables. So you can see we have a lot more patients now, and we have a few new fields. So name's been split up to last name, first name. We have an insured column now, or an insured field, and this is basically just yes or no if they have insurance. And there's an account balance, which states how much this patient currently owes in their account. So made slight changes to the doctor table. I added a scope of practice, and we added a few new doctors. Take a closer look at the last checkup. You can see that each one of these has a record for every patient in our database. It lists basically their vitals at that checkup, and a few notes from the doctor. And importantly, it has when that actual checkup date. And of course, we have the medications table, which doesn't have any changes from last time. It just has some more data inputted for those new patients. So the exact structure of all these doesn't matter too much. What we're going to do in this tutorial is answer the question of how do we actually use that SQL language that we learned about in this tutorial slides. So the way that we can actually input SQL and actually run it in Microsoft Access is by going to Create, and then we want to click on Query Design. So you notice you'll have two options here. You'll have Query Wizard and Query Design. For almost everything we're going to be doing in this course, we always want to click Query Design. We don't want to go into Query Wizard. Query Wizard is a bit of an awkward tool. We want to stick with Query Design because we know SQL and it's going to be a lot more powerful this way and a lot less cumbersome. So we'll click that button. And the first thing you're going to see pop up is this Show Tables thing. Because we're going to be doing raw SQL, we're not worrying about the Query Designer right now. We're not going to be messing with this at all. So we're just going to hit Close. And we want to immediately, we don't want to change any of this, we want to immediately click on SQL View. Here you'll see two different views. This is sort of like we've seen with the tables and the forms. They have a design view and they have another view. So in this case we have design view and SQL view. Design view sort of lets us use the query design tool. We'll get into that later in the video. But first it's really important you know SQL first. So what we're going to want to do when we're inputting SQL is click on SQL view. That's going to simply give us this sort of empty white box that we could put SQL in. And the first thing you're going to see here is that select statement. So unfortunately it is a little bit small text, so you might want to set this video to 1080p just so you can see it the same sort of size that I can. So the reason why we get select is because that's what most of the things we're going to be doing. We're going to be doing select statements. So by default, it's just sort of filling in select for us, just because that's the most likely thing that we're going to be doing. If we want to do something else, like an update, or a delete, or an insert, we'd just get rid of that starting select, and we'd fill it in with what we need. One thing to note is by default, it also adds this semicolon here. Usually that semicolon marks the end of your query statement. So we're going to get rid of that for now, because we're not at the end, we have to still write it out. So we're going to start by sort of putting in the general template that we use for select. So we'll get rid of that semicolon. We'll add a from, and we'll add a where. So in this course, all of your SQL statements have to match a certain format. The reason for this is it makes it a lot easier to read, and it shows that you're actually writing these by hand. So it is important to understand how to write SQL by hand. Many students are tempted to just use the query tool, or the query design tool, because it will write the SQL for you, but there's a lot of problems with that. First of all, if you don't understand what the SQL is that it's writing, you're not necessarily going to have the right statement. The second one is, it doesn't really help you learn SQL. So in Microsoft Access, it's easy to use the query design tool, but when you get into bigger enterprisey systems like MySQL, SQL Server, things like that, they usually don't come with some sort of SQL design tool. Especially if you want to get into programming, sort of tools that interact with databases, it's really important that you understand SQL. For this course, we want to use this format, and we want to write SQL by hand unless you're told otherwise. For this select statement, we're going to have three parts. We're going to have the select part, the from part, and the where part. And this is going to line up just like this sort of statement we have up here. And we have to fill in the blue parts, sort of the what we're selecting, where we're selecting it from, and what are the conditions. So I've moved our query window down to the bottom here and made it a bit smaller. And now we're going to open up the patients table. I'll shrink this down a little bit. Nicely. If you're wondering how I got these to be windows instead of sort of the tabbed view, I switched access into windowed mode. If you want to know how to do that, I do cover that in the extra Microsoft Access example video. It's really a personal preference, which mode you like. This one's nice just because it allows you to see multiple databases at once, or a database and a query. So in this case, we have our patient information up here, and we're going to try a simple query. So what we want to do in this case is we want to select, let's say, all the patients, but we only want to list them by first name and last name. So we just want a list of the patient's first name and last name. We don't want all this other data. But since this is a very simple query, we're not going to need the where clause, so we can get rid of that. We're just going to need to say what we're selecting and where we're selecting it from. So we're going to start with last name, comma, name. I've typed two field names here. So for example, you can see last name. That corresponds to the last name field up here. So the same idea with first name. That's going to correspond to our first name field up there. So basically what we're saying is that we want to select the last name and first name fields. We want to create a list that's only going to show the last name and the first name in that list. Then the next important thing is where we're selecting it from. So that's going to be the table we're selecting this data from. Patient. So by patient, we mean that we are going to select this data, the last name and the first name, specifically from the patient table. We can see that we've typed the query here, but nothing's happened yet. That's because we haven't actually run the query. So after we type it, we have to tell Microsoft Access that we're done our statement, we've done our question for the database, and then we have to actually ask it. We have to run the question. You can see that we have this design tab up here, and these tabs over here that are sort of like highlighted in the background are ones that are specific to the current tool you have selected. So if we clicked on the table, they'd switch to fields and table. If we click on query, it switches to design. So when we want to run this, we have to make sure we have the query selected. Then we click design, and then we click run. And that's going to actually execute this query. So I clicked run, and you can see that it has changed, and it's showing us the results. So in this case, the last name and first name here are coming directly from up here in the table. So this hasn't created a new table, it hasn't copied data or anything like that. It's just simply answering our question. It's sort of showing us what was in the table when we asked the question. So it's not a new table, it is just the answer to our question. And we can save a query if we want to do this query regularly, like if we want to ask a question again some other time. Maybe this is a common question you have for your database. To do that, if you're in windowed view, you can click the Save button up here. If you're in tab view, you can right-click and hit Save. Since we're in the windowed mode, we're going to click Save up here. It's going to ask you a name for the query. So we can call this patient query 1. The naming of the query doesn't really matter, but if we hit OK, you can see a new entry has popped up over here called patient query 1. That doesn't save the data that we selected here. It's not creating a new table. It's not saving this data somewhere. Rather, it's saving that SQL statement that we wrote. So we can run it again later. So if we close that, and we double click this again, we get the result again. So we can ask that question again if our database has changed. So for example, if we call this Joe 2, Jack 5, something like that, and we ran the query again, we can see that it's changed now to Joe 2, Jack 5. So once again, it's not saving the data that we got, it's just allowing us to ask the question over again. We can get back into looking at the SQL by just switching into SQL view. And one thing you'll notice is that it's changed the formatting on us. So that is a bit of a problem for us because we have to use a certain formatting for this course. So in terms of the actual use of SQL, like using it in the database, the formatting isn't important, but the formatting is important once again for this course, just because it's a little bit easier for you to understand the SQL when it's on multiple lines, not all bunched up, and it shows that you're writing it by hand and not just using the query design tool. So we could try running it again, and you can see even though it's a different format, it still works. So I'm going to switch this back. And we're going to make a new, more complex query. Make a query again, we're going to hit Create. We're going to click Query Design. We're not going to use this table thing, we'll just close that. And we'll go right into SQL view. Make the window a bit smaller. This time, maybe we want to ask a little more data. Maybe we don't want just last name and first name, we want last name, first name, and phone number. So let's start that. We know last name, first name, and we know we want phone number. And we're going to say we want it from the patient table. So this looks okay. Well, let's see what happens when we try to run it. That's a bit odd. It looks like it's fine. I mean, last name here matches up with last name up here, first name here matches up with first name here, and phone number here matches up with phone number here. When selecting from the patient table, looks the same. The only thing we're doing differently is selecting an extra field. So what happened here? So pause the video, try to think about it for a little bit. I did mention this in a previous video that we could cause problems. Once you think you have the answer or you don't know, unpause the video. Okay, so the issue here, and I did mention it before, is spaces in field names. So you notice phone number has a space. And I mentioned on one of those early access videos that you're allowed to put spaces in your field names, but it's going to cause problems when we get to SQL. This is one of those problems. The spaces are going to cause an issue because it thinks that you're moving on to the next part of the SQL statement when we're not. So the way we can deal with these field names is, well, you could just rename them, but that might be a bit of pain and it might not be realistic in real life. Maybe you're not the person who designed the database, you don't have control over that, but you still have to write SQL to deal with it. And we can do something to fix this, and that is surrounding the word phone number with a special kind of square bracket. So we use the square brackets like this, and we surround the word phone number, and this just tells Access that this is sort of like the literal name of the field, to ignore spaces and things like that. So now when we try to run the query, you can see that it worked fine. Now it's sort of ignoring that space or treating it as a literal space character rather than thinking we're moving on to another part of the query. So if you have spaces in your field names, you have to surround them with those square brackets. And after you've run a query, if you want to go back into SQL view to take a look at it again, you click SQL view. Let's try something a little bit different. Let's say we want to select the first name, the last name, and the address. So in this case, I'm potentially going to cause an error just to show some things that might happen when you're working on your assignment that might go wrong. So we have a last name, a first name, an address, and we're going to hit run. We get this weird pop-up. It says enter parameter val. Well, I should say enter parameter value, but it's cut off. And it wants to know the parameter for address. That's a bit weird. We're just selecting another field from the database. Why is it asking us for something? And this is one of those really deceptive errors that you can get in Microsoft Access. It doesn't actually say that it's an error. Instead of it's trying to ask you for information. But in reality, for most of the cases we're going to be dealing with, this means you've done something wrong in your SQL. So pause the video, take a close look at that SQL statement here, see if you could think of what I might have done wrong. Hopefully you've thought about it and might have an answer in your mind. And the issue, I'll highlight it here, is with address. Specifically, in how I spelled it. So you can see I left out one of the D's. A DDRESS, but I've left out one of the D's. So what Microsoft Access is doing right here, what it's doing right here, is it's basically just saying, I have no idea what that is. Because it's sort of dumb, it doesn't know it's a typo or a spelling mistake. Instead, it's just saying, I have never heard of this field. What is this? And that's why it's trying to ask you for a value for this field. So we don't want to give it a value because we know we've made a mistake. So if you get something like this, you hit cancel and try to find a mistake in your SQL. In this case, it's that we just had a small typo in our field name. By running that again, now that we've corrected the typo, everything pops up nicely. One thing you'll notice is that even though I corrected Joe and Jack in this first column, we're still getting Joe 2, Jack 5. So the reason for that is also a small mistake on my part, and it is actually can be seen right here. Remember that little pencil symbol? That means this record hasn't been saved yet. So when I edited it and removed the 2 and the 5, it didn't actually save. So we're not actually seeing what's saved in the database right here because of the symbol. It's saying this is what we could save if we hit save. So the query is actually querying what's actually stored. It's not just querying what's on the screen. So that's an important distinction. Usually it won't come up too much because usually you've saved the database. But if you made a change and haven't saved it yet, it's not going to come up in the result of your query. So let's go up here to patient and let's make sure that's saved now. And you can see that it updated down here. Usually the query window will update live. Sometimes you have to run it again, but if you needed to do that, you could just make sure you are in SQL view, go to design, and hit run. Another thing you'll notice is after we've run it, it's going to show a this is called the data sheet, the result, and we don't have that little tab anymore to hit run. Want to rerun it, you always have to go back to SQL view. Maybe let's move on to a little more complex example. So we've been selecting things fine. Well, maybe we want to select all the data. Now we could write out all of these names. I could write out card name, last name, first name, phone number, address, doctor ID, birth date, insured, account balance, and so on. And it would work fine if I typed it in correctly and make sure to use those brackets around phone number because it has a space. But that's a bit of a pain. And what if someone were to update this database? Then I'd have to update my query and insert more commas, more field names. So Access does give us a bit of a wild-colored character, which means select everything from this table. That character is simply just the asterisk. Shift 8 looks like a little bit of a star. So if we run this query, we click run, it's now selected everything. And since we didn't have like a where statement, it's just going to give us exactly the same sort of data that we got in the table. Not quite useful, but it could be more powerful if we added a where clause to be more selective about what where are. We can take a look at that now. So let's say we wanted to find out all of these accounts, these patient accounts, that have a non-zero balance, so anything greater than 0. So maybe what we want to select is the last name, first name, phone number, because we're going to want to call and yell at them for not paying their account, and the account balance. See here that I did put phone number in the square brackets because it has that space. We're saying we're selecting from patient. So far this is good. If we were to run this, we get a list of all the patients and the account balance, but we wanted to only select the ones that have above 0. So in here we could just pick it out, but this could be a database of thousands and thousands of records. So we don't want to do it by hand. And that's where the power of SQL comes in. We're going to add back that where clause. Remember, the where clause is what allows us to actually put criteria on what we're going to return. So we add rules. So we could say, in this case, we only want to return patients that have a non-zero account balance. So the way we do that is we're going to say account balance is greater than 0. So the syntax for these where statements is detailed in those SQL tutorial slides. But in this case, we're saying the field name, account balance, has to be greater than 0. Notice that account balance is in a currency and has $signs in front of it, but we shouldn't put that in here. Because remember, underneath, it isn't storing that $sign. It's just storing the raw number. In this case, we're saying greater than 0. We also don't have to put .0. I mean, that would be fine. We don't have to give the decimal places. We can just say greater than 0, even though this can store decimal places. So let's run this query and see what happens. You can see that it's run. And now the only results in this data sheet are the ones that have greater than 0. So we could call up these patients and ask them why they haven't paid their bill. So if we wanted to save this query, because we might want to do this regularly, maybe once a month, we'd hit save. We can call this pay up and hit OK. Here. So if we ever wanted to come back and check who hasn't paid up again, we could just double click that and it gives us the result. Back into SQL view, we'd hit this. It did lose the nice formatting, but we couldn't run it again. So it's sort of like what we call a saved query. Let's take a look at another example. Let's make a little more complex view of what we just did. So we're going to go create a new query. We're going to go into query design, close this because we don't need that. Go into SQL view, make this just a little bit easier to see. Starting with select. So this time we're going to want to do the same sort of thing. We're going to want to select the patients that have a greater than 0 balance, but this time we only want the uninsured patients. We're going to assume that their insurance are going to pay up if they're insured, so we only want to know who isn't insured and owes us money. So we'll start again with what we want to select, last name, name, and phone number, and account balance. So one thing I should point out is right now I've been typing them in the same order that they occur in the database, but there's no reason to do that. We could, for example, first name first, move account balance to second. I'm just using copy and paste right now. And that's going to change sort of the order the columns are in our resulting data sheet. We always have to have our from, where we're taking this data from. In this case, it's going to be patient. And we're going to have two criteria now. The first one was just like before. We want account balance greater than 0. And we're going to have a second criteria. So it uses the same sort of logic as we saw in Excel if statements, where you have like a criteria and another criteria, or a criteria or another criteria, the same sort of truth tables, but the syntax is going to be pretty different. So by and, we're saying that both of these criteria has to be true for a record to be returned. If we were to say or, it would mean either one has to be true for the record to be returned. So in this case, we're going to say account balance greater than 0 and insured equals false. And we'll give that a run. These patients in our datasheet view, the result of our query, also have to meet the criteria that we specified. So in this case, we said their account balance had to be greater than 0, and it also had to be the case that they are not insured. So you can see with Dave Davis here that he has an account balance of 5, and he's not insured. However, with Bob Jones, he has an account balance of 600, but he is insured, so he wasn't included. Let's take a look at query again. So I said insured equals false. We could also say insured equals no, and that works too. So when you have a field like this, that's a yes/no field, You can use a few different values. It's still the same. You could say true, false, or you could say yes, no. Both are the same to access. They both will work in your queries. If you want to do the opposite and select the ones that are insured and have an account balance greater than 0, we could change that to yes, hit run again, and now we're just getting the ones that have the account balance that's greater than 0, like 620 here, and they're insured. This can be quite powerful because it can make you or allow you to do complex sort of questions on the data in your table. So we'll take a few more examples. So right now we're selecting the first name, last name, account name, and phone number. But maybe we want to find people that have a phone number that start with 519. We have a few different phone numbers here. We have 519 phone numbers, we have 123 phone numbers, and we have 416 phone numbers. What if we just want to find people that have a 519 phone number? So you think we might be able to do greater than and less than, sort of make a range. But the problem with that is phone number in this database is not actually a number, it's a string. So Access is storing this data as text. So the problem is we can't sort of do greater than and less than on strings because it's not going to work the way you might expect. Instead, it's going to be sort of comparing the alphabetical order, like B is greater than A, C is greater than B, and so on, rather than the order we want, which is sort of numeric. So since we can't compare it that way, we're going to try a different approach. We're going to use the like statement, and that allows us to sort of compare different strings or different text. So it looks something like this. So we're going to have to use those square brackets because phone number has that space. So in the where clause, you're also going to have to use square brackets if it has a space in the name. We use the keyword like to say phone number is sort of like this string, but not exactly equal. And we're going to say 519 and a asterisk. So we're going to say, does this start with 519? So by the star asterisk, it's a wildcard that will catch 0 or more characters. So we're saying the phone number has to start with the literal character 5, the literal character 1, the literal character 9, and then 0 or more characters. So this should return any record that has a phone number that starts with 519, and then 0 or more characters. So it could just be 519 entered as their phone number, or it could be 519 followed by any number of characters, letters. We might have validation rules, or we might have input masks that don't allow that. But in terms of this query, it's saying absolutely anything after 519 will match this query. Let's give that a run. And we can see here that we're getting 3 records, and all of them have 519 at the start of their phone number. And that matches up with this database correctly. We have 3 records that have 519. Go back to SQL view. So maybe we wanted to find everyone that doesn't have a 519 number. We can do that with the not statement. So the not statement sort of negates the logical statement. So it says sort of like the opposite of what this is. So if we add not here, say everything that is not like 519. This a run. Now see that we have all the phone numbers that are not starting with 519. And that just goes in front of any logical statement in your sort of criterias to sort of negate it. And let's go back to design view, or sorry, back to SQL view. So maybe we wanted phone numbers that start with 519 or phone numbers that start with 123. We can use our or keyword. I add 2 space just to make it look easier or look nicer, but you only need 1 space here. We're going to repeat the same sort of idea. Phone number, again in those square brackets because it has that space. Like, this time we're going to do 123. And we're going to run the query. Now it's going to say that the phone number can either be like 519 or it can be like 123. And we're getting a list of all the records that have 3 at the start or 519 at the start. So let's give this query a save. Call it phone num in case we want that later, and we'll close it. So, whoops, leave that in datasheet view. So we'll make another query. Close that again. Go back to SQL view. Okay. So this time, what we're going to want to do is select patients that are born between a certain range. And this time, we're going to return the first name, and say the birth date. That would be important. So one important thing to note, like we saw in the last example, you don't necessarily have to, or we saw one of the last examples, not necessarily the very last one, was that you don't have to necessarily select things that are part of your query. You can select whatever you want to display, but you don't have to select what you're asking questions about. So for example, in that query where we're picking out patients that had an account balance greater than 0 and were not insured, we didn't actually display if they're insured or not. So that's fine. You don't have to select things even if they're in your query. You just select what you want to display. From, and we're going to say from the patient table. In this case, we want patients between certain birth dates. So let's say birth date. So you'll notice I'm using a hash symbol now. So this allows us to put it in a date format. In the slides, you'll notice that it uses a slightly different date format. It's going to be based on the local date format of your computer, which should be similar to what it showed up in your actual records. So let's say we want to find anyone who was born in the 90s. So let's say 90, 01, 01. So that'd be January 1st, 1990. And 99, 12, and I'll also put 30. So if we give that a run, we can see the syntax here is birth date between this date and that date. So it's going to find records that are between these two dates. Let's give it a run. And we can see that we get two results. We get Bob Jones and Jack Doe. If we take a look at the data up here, that seems correct. Only Jack Doe and Bob Jones was actually born in that range. So if you want to find a value that's between two values, it could work for any kind of value. It doesn't have to be dates. You can use the between keyword. So let's take a look at another example. Instead of birth date, let's say we want only ones who have a account balance between 1 and 100. Now I'm not using the hash signs because those were just for dates. Instead, we're just putting in the numbers, because for numbers, we just put them in as they are. Strings, you usually put quotes around them, double quotes. Numbers, they go in as they are. Dates, they get surrounded by those sort of hash symbols. This query should return anyone who has an account balance between $1 and $100. Give that a run. And we can see we have 3 results. Notice we don't get the account balance because I didn't add that as a selected field. I still had the same select fields from before, so we're still getting birth date. We can take a check to see if it's working. So we have Davis, he had $5, that's between 1 and 100. We had Jack, he had 35, that worked. And we have Patty O'Brien, which had 20. So it seems to be working okay. One thing you should be doing when you're running your SQL statements is take a look at the result and see if that makes sense. Because it's possible you could write an SQL statement that's perfectly valid, but it's not logically correct. It's not doing what you want to do. So you should always check after it runs that it actually has a result that makes sense. In this case, it does. So we're going to save that. And we'll call this maybe count 100. So we'll have another one up there, and we can always bring it back if we wanted. One problem we might have, and we'll take a look at making a new query for this. Same process. Let's say we wanted to figure out who the doctor of certain patients were. Let's say select. We're going to select the last name, first name, and the doctor ID. From, again, selecting from the patient table. Watch. Actually, let's not put any criteria. Let's just select all the patients in the table. We want to say their last name, their first name, and who their doctor is. Run. So it worked, but you can see it's just giving us the doctor ID, the foreign key. That's not really helpful. I mean, we'd have to actually look up by hand or write another query to figure out who doctor ID 1 is, or 3 or 2 is. So the next part of this video, we're going to take a look at how we can join tables together so we can sort of pull in the other data into our result. So we could actually fill in the doctor name there. So we're going to switch over to the slides again. In this part of the video, we're going to start looking at how we can combine multiple tables and sort of pull data from different tables and combine them together. And what we're going to be using to do that is called an inner join. So the syntax looks something like this. We have that same select from where syntax we've been using in part 1, except there's a new part now called interjoin. And that's going to be telling Access what the second table is that we're going to be pulling data from and how we're sort of like joining those tables together. So we're going to be saying how we're joining the foreign key to the primary key. So if we take a look on the slide, data set 1 would be the name of the first table in many cases, and the second one, data set 2, would be the name of the second table, and the sum condition is true would be conditions that tell Access how we're matching up the primary key to the foreign key. Let's go back to Access, where we see where we left off, and see how we can fix that doctor example. So we're back in Access. Where we left off is we were trying to make a list of patients, last name, first name, and then the name of their doctor. But the problem is we're just getting the foreign key, the doctor's ID, when we want the actual doctor's name here. So let's go back to the query and see what we can do. So if you recall, we need that inner join part. We can take a look at that syntax again. You can see it's inner join, and you can also notice that we have these brackets here. So those are very important. So we're going to include them. And those basically are going to tell Access which tables we're joining together. So the brackets aren't going to matter too much when it's just joining 2 tables, but when we start seeing more complex examples where we get into 3, 4 tables, then those brackets will become very important. So it's a good habit to always include these brackets, but we'll see what happens when we include them or don't include them. So inner join. The next table we want to join, well, what's that table going to be? So we're trying to pull the doctor's name. We have the foreign key for doctor ID, and doctors live in this doctor table up here. See? You can see that we have the doctor ID here. And the way this works is these doctor IDs sort of join up to the doctor IDs in this other table. That's going to be the same as the ID for the doctor in this table. So the name that we're trying to find for this first doctor would be Bob Smith. The name for Doctor 3 would be Charlie Wilson, and so on. So the other table that we're trying to join is going to be doctor, because that's where we're trying to get that extra data from, the doctor's name. And we take a look at the syntax again. You can see the next part is the keyword on, and then we have to give the criteria that sort of matches up those foreign keys with the primary keys. So on, and so our foreign key is doctor ID. So we'll say doctor ID. And we're going to say equals, if we look in the doctor table, and it's listed as doctor ID here too. So we're not going to add a where clause because we were trying to list all the patients right now. But there is something slightly wrong. I remember to include the bracket there. So the bracket would go at the end of this line, just like it shows here. But there is something else that's slightly wrong in this. So you could try pausing the video and seeing what it is. If you have no idea, just keep playing, and we'll try running this and see what happens. matching doctor ID with doctor ID. We're selecting last name, first name, and doctor ID. So let's see what happens when we hit run. We get an error saying join expression not supported. There is a reason for that. And that's because, and I even highlighted where that reason is, this statement's a bit ambiguous. So Access doesn't know what we mean by doctor ID. I mean, there's a doctor ID in this table, but if we look at doctor, there's also a doctor ID here. So they're named the same. So whenever we're joining two tables together, we always, like no matter what, have to give the table name in front of these. We're saying doctor ID equals doctor ID, so we have to say what table we're from. So patient dot doctor ID. This is sort of like a namespace in XML. We're saying where this name is from. So we're saying this doctor ID is from the patient table, and it has to equal the doctor ID from the doctor table. So always in these inner join statements, we have to give the table name. So there's still one other issue with this statement, and it has to do with these select values up here. Might even be two issues. We'll take a look soon. So pause the video, see if you can figure them out. If you don't know, or once you get the answer, unpause and we'll see what happens. We're going to try running. So it says specified field last name could refer to more than one table listed in the statement. What's going on here? So there's still a little bit more ambiguity in our statement. And computers aren't smart enough to figure this out on their own. They need things to be perfectly clear. The issue here is that we're saying we're selecting last name, first name, and doctor ID. But all of these, last name, first name, and doctor ID, actually occur in both tables. So if we take a look at doctor, we can see that doctor has a last name and a first name and a doctor ID, and we also have a last name, first name, and doctor ID in this table. So Access is really confused right now. So when we were just doing sort of select statements on one table, it didn't matter. We didn't have to include the table name because everything wasn't ambiguous. It was really clear what we're referring to. When we start getting overlapping fields, multiple tables that have the same field names, we have to make it very clear. And we do that by adding in the table names. So we're going to do that up here. So we're going to say we want the patient's last name. And we want to say we want the patient's first name. And we could say patient or doctor ID, but remember, we're not actually trying to get the doctor ID. We're trying to get the doctor's name. So instead of saying doctor ID, we'll say doctor dot, do it the same order, last name, and doctor dot first name. So now what we've changed it to say is we're trying to get the last name and first name from the patient table, and we're trying to get the last name and first name from the doctor table. So this will list the patient's name and their doctor's name. Let's try giving this a run now. And we get a nice result. You can see that the names sort of go off. So remember from that first Access tutorial, we can sort of expand these columns by double clicking the line, and that will just size them for us. And that looks fine. We have the patient's last name, we have the patient's first name, doctor's last name, doctor first name, and we all have this nice table here. So we can see who that patient's doctor is. Go back to the query. So this one thing I'll show you that's a little bit advanced is you notice that those names in that query weren't exactly the most nice looking. It says patient.last name. Might not be the best. So we are able to change what they show up as in the report by using the as keyword. So we could say as patient last name. Notice I'm using the brackets here because these have spaces in them. And all as does is just makes it going to display in a different way. How we can make these data sheet results a little bit more useful, a little bit more readable. Let's give that a run. Now you can see these columns have like a more human readable name. So once again, that's just a little extra tidbit for you. You don't have to do that in your assignment, and you're not expected to answer that on an exam. But if you're doing this in real life, you might want to make this query a little bit more usable. You could do it that way. So we can combine this sort of query with a where clause still. So maybe we only want to list patients and their doctor who, again, once again, have a account balance that is above 0. Maybe we were at the secretary and we want to let the doctor know that their patient owes us money. So we're going to use the same where clause, account balance greater than 0. Now it's going to apply the same criteria to the list that we're already making, that's joining the two tables, except now it's only going to include entries that have an account balance greater than 0. So let's give that a run. And now we should only have people listed in here that have an account balance greater than 0. So just to make it a little bit easier to read, we might add in on this long list up here the account balance. Make this a bit longer. Notice that I don't have to put the table name in front of account balance. The reason for that is there's no account balance in the doctor's table. We could look at the doctor's table quickly. See, it only has last name, first name, and scope of practice. So there's no reason for us to put the table name. So in general, you can always put the table name. It won't break it if it has the table name when it doesn't need to be. So it could be safe to always put the table name in because you'll ensure that it works. But when it's not ambiguous, you don't have to include the table name. In this case, account balance only shows up in one table. So we only have to just say account balance. The one exception to that is in the inner join. We always have to put the table name, no matter even if these foreign keys in the primary key were different. In the inner join statement, we always put the table name in front. So let's give this a run. So now we can see the patients, who their doctor is, and what their account balance is. We're going to save this. Let's see if this is pay up with doctor. Okay, so we are going to create a new query, create design view. Once again, we're doing the same steps. Resize it. So maybe we want to do a different sort of example. Maybe we want to create a list of medications a patient has. And we could do that without joining tables if we had the patient ID's name, or the patient's ID. But that's a bit cumbersome. You have to memorize the ID. So maybe in this query, instead of giving the patient's ID, we'll just give their last name and their first name, and then we'll get a list of their medications. So the person we're going to ask about, in this case, I think, let's take a look at the medication table first. So it looks like this patient here with the ID of this health card number, ending in AB, so Joe Bloggs, has quite a few medications. So we're going to make a query that's just going to look up the medication list for Joe Bloggs, and we're going to do that by his name. We're not going to use his health card number, which is the primary ID. So we start with select. In this case, we know it's going to be for Joe Bloggs, so we don't really need the first name and last name. All we're really going to want is going to be stuff from the medication table. So I'm going to move it up here just so I can get a good look at it. So we're going to want the medication name. Probably want the dosage. And we'll put days. We'll just leave out the instructions, just for example reasons. I'm going to be selecting this from. So we're going to start with the patient table. Really, you could start writing this query from either perspective. There'll be slight differences in how the inner join works, but in this example, we'll start with the patient table. So we're going to be selecting from patient table. And this time, I'll leave out the bracket. That's just because we're selecting from one table. When you're selecting from multiple tables, that bracket is required. But I can also show you an example without the bracket. Selecting from the patient table, we're going to inner join. We're going to inner join the medication table. We're using the on keyword to say what the criteria is. In this case, remember we have to use the table name in the inner join. It's going to be patient dot card num. So we're saying the card number primary key right here from the patient table. And it's going to have to equal on the medication table. Take a look. It's going to have to equal the patient card num. So even though that the foreign key is named differently, we still have to add the name of the tables in this case. And we now need a criteria. If we were just to run this, well, we can see what would happen. It's valid syntax, but we're getting all these medications, and they're not all for Joe here. So what's happening is it's just listing basically all the medications in the table because we didn't put any criteria in. So you can see this is just a list of the medications table. It's just sort of joining it with the patients that are there, so it's only showing it for each patient. That's not too useful. We only want to show it for Joe blogs. So we're going to go back to SQL view. We're going to add a where clause. In this case, we have two actual criteria in this case. Because last name and first name are two separate fields, we're going to have two separate criteria. One checking the last name and one checking the first name. So a good task for you right now would be to pause the video, maybe on a piece of paper or just a notepad, write down what you think the criteria is going to be. Remember, it's going to have two parts. So there's two criteria. So write that in Notepad, unpause the video, and see if you get the same answer as I do. Okay, let's take a look. So we're going to start by checking the last name. Last name equals logs. And now the second criteria, and we want these both to be true. So they both have to be true. Notice that there are some cases where last names are the same. Like we have two people with Doe, two people with Jones, things like that. So we are going to want to check both. And they both have to be true. We can't use an or here, otherwise only one or the other would have to be true. So we're saying last name equals blogs and first name equals Joe. So those are our two criteria. We have to match the first name correctly, and we have to match the last name correctly. So let's hit run. And now we're just getting the medications for Joe blogs here, the dosages and the days. So we can double check just to make sure that makes sense. Remember, Joe blogs is the one that ends in AB. I mean, you could have multiple ones that end in AB, but in this case, we just happen to only have one that ends in AB. You can see they're all listed first. We have the Advil, the amoxicillin, and the other one. So it all looks good. And like I said, it is important to check that your queries are giving you the result you think they are. So that's working great. So we're going to save that, and we'll call this one Joe. Or we'll call it Joe blogs med. Okay. So once again, we're going to start up a new query. And I think we can give one more example. So we also have this nice last checkup table here. This lists number of statistics or vitals for patients during their last checkup. Remember, this is one-to-one, so each patient only has one value in here. So maybe we want to figure out who hasn't had a checkup in the last month or so. So we're going to do select the name, first name, last name. And again, if we look at the last checkup, there's no first name or last name, so we don't have to worry about any conflicts. And we'll probably also want to get the checkup date. So you can see checkup date is called checkup date. We're going to be selecting this from patient. We'll start from there. And now we have to do the inner join. We'll do this example with the bracket again. So this bracket's going to once again become important when we start joining multiple tables. Or just joining two tables, you can leave it out. It won't have any difference. So we're going to be inner joining. The table is going to be called last checkup. Using the on keyword. And now we have to include the table names here, even if they are different. Last. You might be wondering if there's a certain order, like do I do patient first or last checkup first? It doesn't matter which order. So we're joining patient card number, that's going to be the foreign key. And we're going to say that it has to equal patient over here. And there's called card number here. So even though that they're different names, we still have to use those table names, just in the inner join part. We can still not use them for select up here. Now, in this case, we want to find people that didn't have a checkup in the last few months. So let's see what we have. So let's say people that haven't had a checkup this year yet, not in 2020. Checkup date is less than. So less than works for dates too, but remember we have to use that hash symbol just to denote that this is a date. So we're saying the date is less than January 1st of this year, 2020. So anyone that hasn't had a checkup in the year 2020, we want to return those people. And we're going to list their first name, last name, and the checkup date. And we're going to hit run. And here we go. We have the list of all our patients who haven't had a checkup this year. So that could be definitely a very useful query for a doctor's office. So let's go back to SQL View. Well, maybe we can make this a little more advanced. Maybe we want to do this, but only for patients that had beats per minute that were over 100. Maybe we want to check on their heart just because they had a resting heartbeat that was too high. So we could expand this where statement by adding an and to add sort of an extra criteria on it. So we could say and BPM is greater than or equal to 100. So by greater than and equal to, we mean we're going to include people that have exactly 100. If we just said greater than, it wouldn't include someone that has exactly 100 heartbeat of 100. We're also going to add in our select up here the BPM, just so we can see the BPMs in the result. It's not required. We could not show that in our result. It doesn't matter if we have a criteria that isn't being selected, but I just want to be able to see that our query is working correctly, so I'm including BPM up here. I'm going to hit run, and we're only getting one result. The reason why is if we take a look at this data, the patient up here, I'd have to look at the table who that is. It looks like it's Jack Doe. Had a checkup date that was in 2020. So even though he has exactly 100, he's not returned because he had a recent checkup. So same for this guy with 130 because he had a checkup in 2020. So the only result we get is Dave Davis. That's because he's the only one that has a BPM over 100 or over than or equal to 100 and also had a checkup date not in 2020. So you can see both of these have to be true because we're doing and. Maybe we wanted or. Maybe we want to list people that didn't have the checkup in 2020 and anyone that has a heartbeat over or resting heartbeat of over or equal to 100. We can modify our query so we get both rather than it has to be both to be selected. So in this case, we already have it saying their date has to be less than 2020 and BPM has to be greater than 100. But if we want to select either or, we change this and to an or. And we hit run. Now we get everyone who has checkup date that's not in 2020, or they have a resting heartbeat of greater than or equal to 100. You can see here that we get Jack Doe. If we didn't go with greater than or equal to, we just said greater than, he wouldn't be included because he has a heartbeat of exactly 100. We have this query now that's going to give us all the patients that haven't had a checkup date in 2020 and have BPM over 100, so that has to be both. But let's say we want to make it a little bit more complex. So instead of just BPM over 100, we want to make it BPM over 100 or oxygen saturation less than 96. So oxygen saturation would be SPO2. But in both cases, whether it's an oxygen saturation below 96 or a BPM above 100, they have to have not had a checkup this year. So we can do that. In this case, we're going to use brackets, and we're going to use the OR keyword. So we're going to put the second part of the query, which is for the SPO2, and we're going to say that it's less than 96, and we put that in brackets. So what it's saying is that for this AND keyword here, saying the left and the right have to be true for it to be selected. So the left would be the checkup date has to be before 2020, and this thing in brackets has to be true. Because we use brackets, it means everything inside those brackets has to be true. So it's like it's doing another criteria statement inside those brackets. So the result of that statement has to be true as well. And this statement, this sort of like sub-criteria, is saying that the BPM has to be greater than equal to 100, so 100 or anything greater, and the oxygen saturation has to be less than 96. Since it's an or, it means it could be either or, like on either side. So either of these could be true for this statement in the brackets to be true, and if that's true, and this side in the AND statement's true, then it will return a record. So it sounds a little bit complicated, but let's give it a run. So we can see the results here, and we can go sort of through them and see why these were selected. So for Bob Jones, their BPM is less than 100. Remember, one of those parts of the criteria was greater than or equal to 100. The reason why they're still selected is because their SPO2 is less than 96. Remember that part of the clause had an or. So the other way around, for Dave Davis, they have a BPM of 110, which was one of the selection criteria that had to be greater than 110. But with the other selection criteria was that it was less than 96. So they're selected because the BPM part was true, even though the SPO2 part was false. Because it was an or, only one side of that or inside the brackets had to be true. Notice, however, that all of them are still before 2020. That's because the left side of the AND had that criteria. It wasn't inside the brackets, so the or doesn't apply to that left-hand side. So for example, we have this value up here was in 2020, and it had a BPM of 100, which would be selected by that criteria that was in the brackets. But because it doesn't have a checkup date before 2020, it wasn't selected. So that example is a little bit complicated, but hopefully if you think about it a lot, and it should be very similar to the if statements we did in Excel, you can sort of work out why those were selected. And I will be providing this database with these queries, so you can take a look yourself, and we'll be calling this one as checkup date. So that was how we join two tables, but now we need to get into how do we join multiple tables together. So in this example, we have patient, we have doctor here, and we have last checkup. So maybe we wanted to do something a little more complex. Maybe we want to return for the patient table anyone who has an account balance that is greater than 0, like we've seen in the previous examples. We want to return both the patient's first name, last name, but we also want to return the doctor's first name and last name. We saw that example, how to combine those two. But we want to combine in even a third table and return the last checkup date. So we want to sort of have a result that's going to say patient name, doctor name, last checkup name, and the account balance, and we only want to select the ones that have an account balance greater than 0. Let's give that a try. We're going to start by creating a new query. Go to SQL view. It's a bit smaller. Making it smaller is just for your purposes, so it's not like hidden behind me. It doesn't really matter what size it is when you're making the query. We're not going to do the whole problem right away. We're going to do it in steps. So when you're approaching a complex problem like this, it is usually best to sort of break it into smaller steps. So let's start by just selecting the patients that we want. So we're going to select the last name, first name, account balance, and we're going to want, let's say, we'll start by matching it up with last checkup, and we're going to also want the checkup date. So we're sort of doing like a simpler version of the problem, and we're going to expand it to be more complex each time. So so we have the patient table up here. We're going to want to select from the patient table, and we're going to include a single bracket because we're going to have one bracket for each table, but right now we're just going to combine it with one table, so we're adding one bracket. We're selecting from patient table. It's going to be an inner join. We're going to be joining it up with last checkup using the on keyword, and we're going to specify how the primary key matches up with the foreign key, the criteria for that. And again, we always have to put the table name here. So we have patient. Primary key is card num. I'm going to match that up with the foreign key over here, which is patient card num. And we're closing the bracket. And we're just going to run this query just to see if it works. So we don't have any criteria. We're just joining up these two tables, patient and last checkup. And we want to see the patient's last name, first name, account balance, and their last checkup date. Let's give that a try. So there we go. We have all the patients. We have their account balance and the last checkup date. So that's not quite where we want to be yet to solve the problem, but it does give us a first step. So the next step is going to be also joining in the doctor's table because we want to get the doctor's name. So since we're adding another table, we need another bracket. So you should always have the same number of brackets here as you do tables you're joining. So we're joining in two other tables, so we have two brackets. You should also have an inner join statement for each and every table that you're adding in. So if you're adding in one table, you have one inner join statement. If you're adding in two more tables, you're adding two more inner join statements. So we're adding another one. And the syntax is the same. This time we're already adding in doctor. We have to do the same sort of thing. Patient. So in patient, bring that up, we have a foreign key of doctor ID. So we want to match up the doctor ID in this column in patient, in this field in patient, that's the foreign key, with the primary key in doctor, which is also called doctor ID, but we can make them different using the table name. We have to provide anyway for the inner join statement. And we end a bracket. So each table has the ending bracket, and at the start we have one bracket for each table we're joining. So let's give that a run and see what happens. Might be something not quite right here. See if you can guess what it is. So once again, we made that same error about having field names that are the same. So the statement was ambiguous. If you recall, when we made this error before, it's the same error. Last name and first name in patient are the same as last name and first name in doctor, the field names. So to correct that, we are going to have to specify the table names, at least for these fields. So we'll start with patient. Patient.first name. And we'll put the doctor on the end here. Remember, they show up in the order that you select them. Okay, so doctor last name. Actually, in this case, maybe we'll just select the doctor's last name. We don't necessarily have to select both. So if we run this query, That fixes our error. Make everything visible. So now, right now, for every single patient, it's listing the patient's last name, the first name, and the account balance, the checkup date, their last checkup date, and the doctor's name. That's still not quite what we want. We wanted to do that, but only for the patients that had an account balance greater than 0. So on the end of this, we add in our where clause. So it's looking complicated, but if you just keep it in these different blocks, and this is one of the reasons why we want you to format it like this, it makes it very easy to understand. So this first block only describes what you're selecting, what fields. The from selects the primary table that you're working with, and each inner join is another table that you're joining in on this. So since we're joining 2 extra tables, we have 2 inner joins, and we're going to add the where part, which is the criteria. And we're going to say it's greater than 0. And let's give that a run. So now we only have patients that have account balance greater than 0. So maybe we want to make that a little bit more complex. We also want patients that haven't had a checkup date this year. So it's the same sort of criteria that we saw in the last example, except we're doing both. So it doesn't matter that these are fields from different tables. As long as we're joining them, we can do a criteria on any field that's been joined in. So we run that. Oh, so it looks like I made a little mistake here. See if you can figure out what error I did. Remember that this little weird enter parameter value means that some kind of error happened. So pause the video. You think you know what I did? Unpause, or if you have no clue, unpause, and we'll see what the solution is. So if you remember, when you get a pop-up like this asking you to enter a parameter value, it's most likely that you made a little error saying the field name, because it's saying, I don't know what that field name is. So let's take a look. So it says check update in this field name up here, but I wrote checkup data. That's not correct. So we fix the typo, and we give it a run. And now we're only selecting patients that both have a positive account balance, a non-zero account balance, and a checkup date that was before 2020. So that's pretty useful the way it is, but maybe we can go even further. So we have a lot of tables here. Maybe we want to make this a little bit more complicated. Let's take a look at the relationship tool. So you can see we have last checkup, patient, and doctor, so we're sort of connecting all of these tables. Maybe we also wanted to add in the medications table. Maybe we want to list the list of medications for these specific patients. So we're going to add another inner join, because we're adding another table. We want to connect in on that patient, or the patient to the medication table. We're going to have to add an extra bracket up here, because we're adding one more table. We should have a bracket for each table. And join the medication table. Patient table, and it's going to be the primary key is card num. So it's going to be this column or field on the patient table, and on medication, we want to line that up with patient card num here. Patient card. And we have to close that with a bracket once again. So in theory, this is adding an extra table. So what it's going to do is it's going to print a list of the medications for each patient that has an account balance greater than 0 and a checkup date that was before 2020. So let's give that a run. So it's working. You can see that another patient was listed twice. So what's happening here is it's listing each patient once for each medication in this table. So Jane Doe here has multiple medications in the table, so she's listed once for each medication. But we can't see the medications yet because we didn't add any more selects. So let's add in. Actually, let's add it at the front. We're going to add in the medication name. We don't have to add the table name because no other table has medication name as a field. So we can give this a run and see what happens. So now you can see that we have the medications added here. So we're getting a list of all the medications for all the patients that have an account balance greater than 0. They have a checkup date that's before 2020, and we're also getting the checkup date listed here and the doctor's last name. So it is quite a complex query. Might be a bit more complex than what you're going to run into on the exam or the assignment, but it is important that you understand more complex queries like this. I'll save this one as applications. So there's one more example we should talk about when we're talking about inner joins. Let's see if we take a look at this relationship table. All these joins we've been sort of doing have been on one-to-one or one-to-many. We should also try to do one for this many-to-many relationship here. So we have doctors, we have orders to tests. So what we're going to try to do is make a list of all the doctors and what tests they've ordered. I'm going to create a new query. Go to SQL. And let's take a look at what we have. We've got the doctors table. We have the orders table. This is that relationship entity that sort of joins up doctors to orders. And it also has a relationship attribute test date. And we have tests. So we only have 2 types of tests right now. So there's not a ton in these tables. But let's try to make a query that's going to select all of the tests the doctor's done. It's going to list the doctor's name, their last name. It's going to list the date the test was done, and it's going to list the name of the test. So we're going to be joining these 3 tables, sort of joining for that many-to-many relationship. And the syntax is exactly the same we've seen. It doesn't matter in terms of our syntax if it's many-to-many or not. It's going to look the same. So in this case, we want the last name of the doctor. This time we don't have to put the table in front because we don't have that patient conflicting with it, so we're free to just use last name. We want the test date, and we want the type of the test, type name. We're going to select that from doctor. So we're joining 2 tables here, so we want 2 brackets. It's going to be an inner join. The first one we're joining is going to be orders. And we're going to be joining it on doctor ID. So doctor ID is the primary key of doctor, and doctor ID is the foreign key here on orders. So it connects to doctor through this foreign key, and it connects to test through the order ID foreign key. So we're going to say, remember we have to give the table name in this part. We end that bracket, and then we're going to have another inner join to connect it to the test table. So we're joining doctors to orders already. Now we need to go from orders to test. So what's going to join that up is the test ID. So we're going to say we're joining test. We're going to join that on orders dot test ID. Remember order ID here, it's just a surrogate key for this table, meaning that it's just an ID we added to serve simply as the primary key. It's not a foreign key for either of these. So we can ignore order ID. We're just trying to link up the foreign ID, test ID, to the primary key test ID over here. Test and D. Gotta have that closing bracket. And we don't have any criteria because we just wanted to make that list of doctors and the tests they've ordered. Let's run this query. You can see here that we're getting 3 results. They all say the same test name, because if you look in the orders table, they're all for the same test, and that corresponds to CAT scan. We get blogs here twice, because if we look in the orders table, we have Dr. Blogs listed twice. Their ID is 2. Blogs up there to Alice Blogs. And we get Smith once. Though notice, even though we have blogs twice and CAT scan twice, it does have a different test date. If we did something like change one of these to a 1 and save that change, we can see that this updates to MRI. So we'll save this as, and we'll call that Doctor Tests. So before we move into inserts, deletes, and updates, there's one more subject we should talk about, and that's the order of these results. So let's take a look at this query we just made. So if we look at the results from that last example, we can see it's not really sorting it in any kind of particular way, just how it kind of wants, based on how the data just happened to be in the tables. Maybe we wanted to change the query so it orders these results by the test date. And we can do that. SQL does have a feature for that, and that is the order by feature. So order by sort of adds another block on the bottom. It always goes on the very bottom after your where clause, or after your inner join if you don't have a where clause. And then you just say the field that you want to sort it by. So in this case, we're going to say test date. So we're basically saying sort this by the test date. If we run it, we can now see that they're in ascending order by test date. What if we want it in descending order? Because ascending order is the default when you just give a field name. To get descending order, you type des right after the field name, and then it will sort it by that in descending order. So when we run this, you can now see that it's in the opposite order. So that's a fairly simple example. Let's see one where it's a little bit more complicated. So I think we had a few queries like pay up, where we're getting a list of patients who had a account balance that was positive. But they both have a last name and a first name. So sorting by that's going to be a little bit more complicated because, for example, we have 2 Does. So if we're just sorting by last name, we might not necessarily put them in the right order by first name. It's not smart enough to know that first name is also part of their name. So we can account for that in the query. So here, this was a very simple query. You'll notice that it's changed the formatting on us because I retrieved it. So I'm going to quickly fix the formatting, like our preferred format. Notice it added that semicolon on the end. So the semicolon on the end is optional in Access SQL, which just means this is the end of the statement, or feel free to leave it off in our cases. We're going to order by, and we want to sort by the patient's name. So if we look at in database, and we wanted to sort by the last name and the first name. So we're going to select last name first, then first name. So we're going to give preference to the last name. So the first one you list gets preference. So we're saying sort by last name, then comma. Then after we do that, if there's sort of like any ties, sort by first name. So you can give any number of field names, and the one on the left, most left, is going to have the higher preference. And then I'll go to each one after that if there's sort of ties. So let's run that. So you can see that it's sorting by last name, and then it's sorting by first name. If we wanted to switch the order, so it's descending, we would have to add in the descending keyword after each field name. Just after each field name in this case, because we want both of those to be descending. If we had a third field that we didn't want to be sorting as descending in like sort of the tie break scenario, then we would not put in descending there. So in this case, we're saying sort by last name and in a descending order for last name. Then if there's any ties, sort by first name in a descending order. There we go. So now it's sorting in reverse alphabetical order by last name and then by first name in the case of any ties. So that one's pretty straightforward compared to the inner joins and those sort of where clauses that we've seen. List the field name you want to sort by. So before we move on to SQL commands that can manipulate your data, like insert, delete, or update, we're going to talk a little bit about the count function. The count function is a special function in SQL that allows us to return sort of counts of how many records we're finding, or how many records are in the database with valid data. So this can be quite useful if we want to ask a question like, how many patients are there that have an unpaid bill? Or how many patients are there that have a bill that's completely paid off? How many patients are there that have insurance? So what we've seen so far, we could just return a list of patients, but it'd be sort of a pain to manually count them to see how many they are. In some cases, we want to just return a number saying there's this many patients. So in this part of the video, we're going to take a look at how we can do that with the select command, and also how we can do that with inner joins like we saw before. So you see on the screen right now is the syntax for the count function. Usually we're going to be using this in select, and it basically replaces a field name in the select statement. So you can see here that we would have our normal select statement. We have the database or the query that we're going to be selecting from. We have the criteria that we're going to apply this selection. Where the count function comes in, it means instead of returning some sort of field values, we're going to actually return a count of the fields. So it's very similar to the count function in Excel, in that it counts how many times a value occurs in those fields. And it only counts when there's actually a value there. If one of those fields has a null value, it won't count that. So we'll take a look at how that works. So up on the screen right now, I have that doctor's office example again, and we're already right into a query. So in this query, what we're going to want to do is count the number of patients in the patient table. So you can see the patients up here, and we're going to start by saying select, and instead of giving a field name, we're going to do count. And one way we can use this is with just an asterisk. What the asterisk means is we're not counting a specific field. It means that we're counting the number of records returned by this query. So we're going to return the number of records in this database. What database is it? We have to say, and it's going to be patient. So it's a very simple query. We're saying count the number of records in patient. When we give that a run, we get something called EXPR1000, and it says it's 7. So 7 is correct. There are 7 patients in this database, but the EXRP1000 is a bit weird. So let's take a look at our SQL. So what's going on here is, unlike in the other examples we've seen where we had field names that it could nicely display above, we just have count. So Access is sort of just filling in a name for us. So one thing we should do when using count is probably give it a more descriptive name. And we can do that with the as keyword. We did see an example of this in the SQL tutorial, but if you forget, it just lets us use a different name for the field when we're displaying the results. So we could say as, we could say num patients, and that just means instead of the EXPR thing, it's going to say num patients. So let me give that a run. It says num patients and 7. Let's go back to SQL view. So instead of an asterisk, we can also put in a field name. In this case, we'll go with phone number. Notice that I'm using the square brackets again because phone number has a space. And when we run this, it's going to count the number of phone numbers. Not distinct phone numbers. If 2 of these were the same, they'd still be counted. It's going to count how many values there are, just like the count function in Excel. So we run that and we get 7 again, which is what you'd expect since there's 7 phone numbers. Let's go back to SQL. Well, let's see what happens when we delete a phone number. Remember, phone number is optional for this one, so there are allowed to be null values. So we'll take a phone number out. Okay, we're going to hit run and see what happens. And you can see we get 6 now, because it's counting how many values are actually in the phone number field. So that means if we have a null value like we do here, when there's no value, it doesn't get counted. If we were to input the exact same value as above, so both of these have the same phone number, make sure we save. Oops, just click design view for the wrong thing. Make sure you go into SQL view. Okay, so if we run this again, now that we have 2 phone numbers with the exact same thing, and we run it, we still get 7. That's because, like I said before, it's not counting distinct values, counting the number of values, just like the count function in Excel. We're going to hop back to SQL view. And now maybe we only want to count how many patients have insurance. So we'll change this around a bit. Now we can say insurance here, or insured. We're going to change this to be num insured. That'll just display the field name differently. And now what we have to do to make sure we're only counting the number that are insured is add a where clause. And this works just like with select. So we're only going to be selecting records where insured is equal to yes. And we'll see what happens. So we get 3, and that looks to be correct. There's 3 that are insured. So you can combine this with any kind of where clause you could in SQL, and it works fine like that. So now we're going to take a look at a little bit more complicated example, and we're going to switch over, taking a look at the doctors and the tests. Or these are the tests they ordered. So in this case, we want to count how many tests Bob Smith ordered. So we're going to use count again. And maybe we'll go with order ID here, since order ID is unique along these tests. We'll call this Bob's test, because we're going to be looking for the number of tests that Bob ordered. We're not going to be selecting from patient anymore. We're going to be selecting from orders. And one easy way to do this would be just to say the doctor ID equals, in this case, Bob is number 1. We say doctor ID equals 1. This is going to return all of the records in order with an ID of 1. And it will tell us how many tests he's ordered. If we give this a run, we just get 1. Because if we look in here, there's only 1 entry for doctor ID of 1. But maybe we want to make this a little bit more complex. Instead of giving it by doctor ID, maybe we want to do it by their actual name. So in that case, we're going to have to join a table. And that works just like it would with our normal select. It's nothing fancy just because we're using a count. So we're going to join it, or we're going to join orders. Or let's start with doctors. Join doctor. Inner join. Going to join orders. We're going to do that on, remember we have to give the table name. I'm going to join it on doctor ID. And now instead of doctor ID, we're going to say last name equals, maybe we'll go with a different doctor this time. Let's go with blogs. So we're not going to specify the first name. That might be a problem if there were more doctors with different last names, but we only have 1 blogs, so it'll be fine for now. And instead of Bob's, we'll call it blogs. This is just renaming the field. It's not actually required. Let's give that a run. And we can see 2. Because if we look at blogs, they have ID 2. And we can see 2 occurs once and twice. So there's 2 tests. So Alice Blogs has ordered 2 tests. So it's fairly straightforward if you're familiar with that syntax for select. You're just using count as one of the field names. So now we're going to move on to part 3, insert, updates, and deletes. These are queries that allow us to actually alter the data in the table rather than just sort of asking questions about it and getting a result. We're going to start with the insert query. This query allows us to insert new data into the database. And the syntax shown here is insert into, these would be the keywords, the table we're inserting it in, which would be in red here, the columns that we're inserting data into, and the values we're inserting. So that might seem a little confusing right now, but we can take a look at some examples. So we have the doctors table up, and what we're going to try to do is make a query to insert new data, or a new doctor, into this table, so a new record. So we're going to start with insert into, and then we put the table name, in this case it's going to be doctor. And now we have to provide a list of field names. These are the field names that we're going to provide values for. So it's important to keep in mind what fields are required. So in this table, we have doctor's ID, which is an auto number, so it's going to figure that out for us. It's going to just increase it by 1 each time. We have last name, which is required. We have first name, which is required. And we have scope of practice. That's one that's not required. So at a minimum, we're going to have to give it a last name and a first name. So I'm going to put last name and first name. And then we have to give values. So we're going to use the values keyword here. And then we list the values in brackets. So these have to occur in the same order that we listed them up here. So since we listed last name then first name, we're going to have to put the last name first and the first name second. So because these are strings or text, we have to surround them with double quotes. We can't just type in, for example, dough, something like that. We have to surround it with double quotes. So all strings in these queries have to have the double quotes around them. So dough is going to be the last name. And we'll say John. And that's our query. So it's going to say we're inserting into doctor, that's the table. We're going to insert the field names, where we're going to insert values for the fields last name and first name. And these values are going to be Doe and John. So these have to occur in the same order as we listed up here. So since we listed last name first, we list the last name first in the values. Since we listed first name last, we have to list it last in the values. We run this query in the same way we would with the selects by hitting run. So this is going to ask us, are we sure we want to do this? Because this is actually going to alter our table in some way. So when we run queries where it's actually going to affect the data, we usually get a pop-up saying, are you sure? If you're sure you want to run this, and it's going to tell you how many rows it's going to affect, in this case we're appending or adding 1 row, you hit yes. You notice nothing happened to the table. That's because you either have to close it or open and then open it like this. You can see it's added now. Or you have to hit the refresh button up here. It won't update it live. So we got a new entry. We got John Doe. It started at 7 just because that's where the auto number had to be at the time. So let's try another example. In this case, we're going to list stuff in a bit of a different order. We'll list first name, scope of practice, and then last name. So now we have to list the values in the same order. So this time we list Jane. So that's the first name because we switched around the order here. If we list scope of practice, let's call it B. And last name, we'll go with Doe again. You can see now Doe's last name because we listed last here. Run. And we have to hit refresh to see the change. We can see that it added that record. So each time we'd run this, we would try to add that record again. So if we ran it again, and we refresh the table again, you can see that it added yet another entry. So if we did something wrong, like let's say we left off last name, it's going to cause some issues because last name is a required field. So if we leave off a required field like this, and we try to run, I'm going to say you're about to insert 1, or sure you want to go do that, and then we get an error saying that this field can't be set to null, meaning that it's required, we have to give a value for it. So it's asking you if you want to run the query anyway. In this case, it won't work no matter what we do, even if we say yes. It's still not updating it just because it's required, so it's not possible to add in a value when it's missing the required value. Similarly, if we put last name back, and we try to set doctor ID, something that's not allowed, like let's say we're going to set it to 2, even though there's already a value for 2, and we try to do that. We hit run. Let's say you want to run this, and then we get an error because there's already a value for 2. We can't have 2 primary keys with the same value. So it says, are you sure you really want to do this? It's going to cause an error. Hit yes. And if we refresh, you can see nothing actually changed because that's not allowed. You can, however, let's see what happens if we try to give this a new number. So we're saying we're going to set doctor ID to 12. Let's give it a different name. So I'm a duck. And if we hit run, let's see what happens. It says you're going to do this. For sure. You see it was successful. And now you can see that there's a I'm a duck record. So you are allowed to specify the primary key, even if it's an auto number, for your queries. But the next thing that will happen if you try to enter a new record, like we can try doing it manually up here, is that it's going to start using at the next number. So if you sort of jump ahead in the auto numbers, it's going to move the auto number up to that point, and it's not going to reset it. So all new values are going to start at the number afterwards. We are allowed to sort of skip backwards using the update query. So we could put in a value at 11. And that's allowed as long as, I'll also refresh it. Basically, it's allowed as long as there isn't a primary query that already exists. So in some ways, this insert query is a little more flexible when it comes to auto numbers, because you're allowed to insert your records at any point in the auto number sequence. However, whatever the greatest number was, the last big number, is going to be where auto number leaves off for new records when you're not specifying the primary key. So big things to remember for the insert is the values have to come in the same order as you specify them up here. So if we were to put doctor ID in the middle, but we don't update the values down here, let's make it 10, so it's actually a valid one. We're going to have some issues because now it thinks first name is 10, doctor ID is Ima, and last name is Duck. So when we try to actually run that, it's going to say that there's mismatches in the type because doctor ID has to be a number and we're trying to set it to a string. So we have to be careful that these go in the same order. And that order is whatever we specified up here has to match down here. The order can be anything we want, but it just has to match up correctly. So the insert's pretty straightforward. So now we're going to switch over to the syntax for the update statement. So this is the same sort of idea as insert, except we're going to be altering the data that's already in the table instead of adding. So this bracket data. So the syntax is a bit different. It's more similar to the select syntax. It's going to say update, the table we're updating here in red, what we're going to be changing. So you say column name or the field name equals this new value, column name 2 equals this new value, and so on. This could be a long list, however many different fields you want to change. And then there's some criteria. So it is important that you provide criteria because this can alter multiple records at once. So if multiple records match this criteria in purple, it will alter all of those. So let's take a look. So we're going to start with update. That's the keyword for updates. And let's try to fix some of the stuff that we put in. So the first thing we did is John Doe doesn't have a scope of practice. So let's try to fix that. So the table is doctor. We're going to set the scope of practice. And we're going to give it a value. Let's make him a cardiologist. So this could be a long list of different fields that we're going to update. In this case, we're just going to update one field. And now it's very important that we have some criteria. If we just ran this query without having the where, it would update all of the records in the database with cardiology, which is definitely not what we want. We only want to update it where it's John Doe. So we could do that by primary key. We could say doctor ID equals 7. If we run that, it's going to ask us if we want to update. And you can see that it's updated the record to cardiology. But we could also do it based on their first name, last name, or any other criteria. So let's try it with last name. Do it Doe. And we're going to have to say and first name because there's multiple Does in here. John. And now, instead of cardiology, we'll set him we'll update him to a different value. Let's move him to pediatrics. And when we run this, we can see that he's been updated to pediatrics. So in this case, we did it by his last name and first name value. So this is saying anything that matches this criteria, both last name and first name, would be updated to this. So we can give an example of where this is going to go a little bit wrong. So what if we only said last name equals Doe, and we didn't say both last name and first name? Now instead of pediatrics, we'll just change it to something new. We'll call it primary care. So we're thinking we're going to update the doctor. We're just going to give their last name and set it to primary care. But the problem we're going to run into is there's more than one Joe in here. So what's going to happen? So we run it, and a big hint that something's about to go wrong is it says you're about to update 3 rows. So if you're expecting to only update a single row and it says like 3 rows or more rows, then you're probably going to want to hit no. But if we went ahead and hit yes, we could see that it updated all of them where it says last name. So it's not just updating one record, it's updating all records that match a criteria. And we can see here that we updated them all to primary care. So we also can update more than one value in a record at once. So we have primary care here. Let's change it back to pediatrics. We can also change the last name. Make it Brown. And we'll do it by doctor ID. And we're going to say we're going to update, since we have 2 Jane Does here, we're going to make one a Jane Brown. And we'll make it the one with ID 9. So now we're listing 2 different fields to update. We're saying update the scope of practice to pediatrics, update the last name to Brown. So we'll update both of those. If we don't list any field in the set, it's just not going to update that part of the record. It's going to leave it as it is. So in this case, we didn't include first name, so it's not going to alter their first name. That. Sometimes you have to click on it before it will update, and you can see that it updated their last name to Brown, and it updated their scope of practice to pediatrics. So it's fairly straightforward. We don't have to worry about joining tables in most of these cases. So you just say update the table you're updating, set the fields you're going to change, the values that are going to change, and then the criteria. So we can take a look at another update example using numbers. In this case, we have the patients table now up. So we're going to create a query, just like we were before. We're going to go into the SQL view. Make it a little bit easier to see both. And now it has select by default, but we're going to want to change that to update. We're going to be updating the patient table in this case. And what we want to do here is we're going to want to update the account balance for Jack Doe, and we're going to want to do it by their first name and last name, and we're going to set that account balance to 0. So we're going to set the account balance set to 0. Notice because this is a number, we don't have quotes around it. We only do that for text. We're going to say where it's going to be last name equals Doe, and first name equals Jack. We have quotes around these because they are text, and we'll take run since we're going to update one record. And we refresh, and you can see his account balance is now 0. If we wanted to set it back to 35, we could change it and run it again. Update one row, and there we go. So that's pretty much it for the update query. It's not too complex, so we're going to move on now to delete. So delete is going to be exactly what you expect. We're going to be deleting a record from a table. So the syntax works like this. You say delete, asterisk, from, and then you list the table that you're deleting something from, where, and the criteria that has to be matched. So you're going to have to be really careful with delete, because it deletes everything that matches this criteria. So if you put the wrong criteria in here, or no criteria, it's very easy to delete everything in your table. So you want to be really careful to look at that pop-up and says how many records you're deleting. So let's go back and, I'll leave this up actually, go back and take a look at that doctor table. So we added some sort of junk data in here when we're looking at the insert queries. So maybe we want to clean that up a bit. So we have these two ducks. We want to get rid of these ducks. They're not doctors. So delete asterisks from doctor. That's the table we're going to delete from. Where? So in this case, we could just say where doctor ID equals 11, or we could say where last name equals duck and first name equals Ima. But we could actually do something a little bit more fancy and get rid of both of these entries at once. So what we're going to do in this case is we're going to say last name, like. Remember, the like word is sort of comparing strings or comparing text rather than it being exactly equal to. We can say that sort of starts with something. In this case, we want to say that it starts with duck, and it could have 0 or more characters. So it would match this one because it's duck and then have 0 characters. It would match this one because it would be duck2, that's 1 character. And it can be any character, so number, letter, anything like that. So we're going to say delete any record from doctors that has a last name that starts with duck. So let's run that. It says we're going to delete 2 rows. That's good because that's what we expect. We wanted to delete both of these that had duck in it. And we hit yes. And you can see it showed up as deleted. That's just because it hasn't been refreshed yet. We click refresh, and they're gone. So if we wanted to delete a specific doctor, we could do it by ID. Say doctor ID equals 9. This will delete a doctor ID with the ID 9. So if we run that, it should get rid of Jane Brown. 1, that's a good sign. We're only wanting to delete 1 in this case. And refresh, it's gone. And we could delete it by their first name and last name. So the last name equals Doe. And if we run this, remember, we're only saying last name equals Doe. Click run, it says 2 rows, but we only wanted to delete Jane Doe. So we should probably say no now. This is a good sign that something went wrong. So if you look and you see that the number of rows being deleted isn't what you expected, you want to say no and see what could be up with your query. In this case, we said just Doe, so it's going to delete everyone that said their last name is Doe, when we want to only specifically delete Jane Doe. So we have to have and name equals Jane. So this is only going to delete doctors where both their first name is Jane and their last name is Doe. If we change this and to an or, it would delete any doctor that matches either one of those things. We want and in this case because we want both to be matched. So we hit run. This is 1 row, which is a good sign. And we'll refresh. And it's gone, just like we expected. So that's pretty much it for the delete statement. These sort of update statements are a lot more simple than what we've seen with the select. But you should make sure that you have a good grasp of them. Even if they are a bit simple, you should understand how they work and how they're going to affect your data when you run them. Because these ones are actually the more dangerous ones. They might be simpler, but they'll have a bigger chance of actually screwing up your database, deleting all your data, or altering records. Because remember, the select is sort of like read-only. It's only reading the data and showing you a result of the query. Well, these sort of action ones will actually edit, delete, or update your records. So you always want to be more careful when you're writing one of these. So that was a short part, and we're now on part 4, where we're going to start talking about the query design tool. And remember, we've been clicking query design all this time to get us into the query design tool to write queries. But like I said before, it is right next to the query wizard. So we want to make sure that we're using the query design tool and not the query wizard. So like I said before, the query design tool is a great tool. It makes it really easy to design these queries without writing SQL. but you really shouldn't be using it. You shouldn't be using it unless you already know how to write SQL. So unless you know how to write SQL, you're pretty good where we are so far in this tutorial. You know how to do all those examples that I've showed you. Then you can move on with this next part. It is so important that you know how to write SQL before you move on to this tool, because a lot of students get into this trap of using this tool rather than trying to actually figure out and understand the SQL that this tool is generating. So once you have a good understanding of SQL, continue on with this part of the video. So I'm just going to close this for now. And we are going to go create and design query just like we were before. But this time we're not going to just exit out of this. We're going to actually select some things. So we're going to try recreating some of those queries we did before in SQL, but using the tool. So one of those big ones that we kept referring to was checking if a patient has an account balance that's greater than 0. So we're going to start working on that. And the first thing we have to do is select the tables that we're dealing with. So since we're going to do a simple version where we just want a list of patients that have an account balance above 0, we're only going to select one table. We're just going to click the table name and click Add, and you can see it show up here. It should be very similar to your relationship tool that you've seen before, except this time we're not editing relationships for the whole database. We're just sort of showing how relationships work for this specific query. Since we're only dealing with one table in this case, we don't have to add any others. We don't have to set up any relationships. Just add the one and hit close. If you want, you can make this a bit bigger so we can see everything at once. And down here is going to be the list of fields that we're dealing with in this query. So one of the fields we're going to have to deal with is going to be first name and last name. We want to deal with these in that we want to actually show them. We want these to be part of our report. So since we want these to be part of our report, we could drag them down here. First name, and it says show. So show is sort of the equivalent of select in the graphical tool. That means it's going to show it in the result of the query. Instead of dragging it down, we could also just go over here and select it, one of our fields. In this case, we also want to show last name, and we also want to show account balance. If we were to just run this query as it is now, it's just going to give us a list of all the patients in the database with their first name, last name, and their account balance. Nothing else. So we can take a look, and just like with SQL, we can run these queries clicking the Run button. And we get the result. Just like we expected, these are all the patients. We can actually bring up the patient table to confirm. This query has brought up all the patients and their account balance, but we wanted to also filter this so it's only going to show the ones that have a balance above 0. So we're going to go back to the query design tool. Bigger again so we can see everything. So another part of this is the criteria section. So we can highlight show or click the show button to show or hide one of these, but we can also add criteria. So we can take a look at what happens if we don't show one. So if we uncheck last name and we run the query, you can see it's not showing it now. We only have first name and account balance. So we're going to check that and we run it again, and you can see last name's back. So this checkbox here is showing what's shown, but we can also apply a criteria. So this is where we would set criteria, sort of like we would in the where clause in SQL. And instead of writing out the whole criteria, it already knows we're talking about the field that we're in the column for. So we only have to type in the last part. So in this case, greater than 0. So we're saying the account balance, we're going to show it, and it has to be greater than 0. So if we run this query, now it's only showing in our list here first name, last name, and account balances for patients that have a account balance greater than 0. Back. So if we also wanted to add in the phone number, if you remember that in that example before, we wanted the phone number so we could actually call the patients that owe us money. We could either drag it from up here, or we could just select it in this dropdown. And we just make sure that it's selected with show. And when we run the query again, we can see that we now also have the phone number. So it does make this pretty easy, at least for these simple cases. But if you wanted to also take a look at what the SQL would look like for these examples that are for these queries that you're designing in the design view, you can still go to your SQL view like we were if we were writing SQL, and it will have the SQL version of what it did. The problem here, though, is it's not following that nice formatting we do in class, and it also tends to add some sort of weird things because it's computer generated. You can see that in its where clause it added a ton of brackets around the where clause for no real reason. But it also, on the other hand, it is smart enough to add the brackets around phone number, so we didn't run into that problem. But it also adds in the table names all the time, even when they're not required. So it tends to generate a lot more clunky SQL that looks a lot worse, and it's a lot harder to read. So it's one of the reasons why you really wouldn't want to be using this tool normally. It's good for sort of learning, and it's good if you just have a quick query you want to put together, but it's not really good for making SQL that's going to be run a lot of time, or it's going to be part of some kind of application you're programming, or if you wanted to have finer level control. So we can take a look at a few more examples. This was a fairly simple example, but we could also do stuff like we want to add in a second criteria. So one of those examples from previously, we wanted to see if the account balance was greater than 0, and they did not have insurance. So we can drag insurance down here, and we have to add another criteria here. So in this case, since it's a yes/no box, we could say equals no. And now when we run the query, we get the list of patients that are uninsured and have an account balance greater than 0. But if you remember that example from previously in this video, we also didn't want to show the insured thing. It's kind of redundant since we already said they had to be uninsured, so showing us that they're not insured again doesn't really give us any additional information. So we'll go back to the design view, and to not show the insured column, we simply uncheck the insured show box. So we can still do a criteria on a field even if we're not showing it. That's completely fine. We just uncheck that box. So when I hit run, now the insured column's gone, but it's still using it as a criteria. So it's only going to select the patients that are uninsured and owe us money. And if we want to take a look at the SQL for that, you can see that it added in the extra criteria here, and that it doesn't have insured up here in the select. So you should be able to understand this SQL that the query tool is generating. So in this case, we're going to take a look at a more complex example using the query design tool, and we're going to involve two tables. So what we want to do is we want to print the patient's first name, last name, their phone number, and we want to also show the doctor's actual name, not just their ID. We want to put their last name. So it should be a list with the first name, the last name, the phone number, and the name of their doctor, their last name. So we're going to start by creating a query. And this time it's going to involve two tables. The first one's going to be patient. So we click add on patient. And the second one is going to be doctor. And you'll notice that it automatically filled in the relationship here because it was already defined in our relationship tool. If for some reason it wasn't already defined, or there was some other foreign key we wanted to link up just for this query, we could pull it over just like we do with the relationship window to set up additional relations for the purpose of this query. So in this case, we want the first name of the patient, and another way we can put it down here is just double click. We want the last name, double click. We want the phone number, double click, and we're going to want the doctor's last name. So we clicked all those, they all showed up down here, and if we hit run, we get the result. It's really easy. We didn't have to worry about joining or anything like that. It did all the hard thinking for us. That's both why it's good and bad, because you're not really learning anything, but you also don't have to think too much about it to get the result you want. So in this case, we got all these patients, we got the doctor, we got the phone number. Maybe we want to add some more criteria onto this. For example, maybe we only want to list patients that are in the 519 area code. So we're going to have to add a criteria to phone number. In this case, if you remember, we have to use that like keyword. Like was saying that the strings are like each other, but not completely equal. We'd use equal if we wanted to find something that's completely equal. Like sort of allows us to use wildcards to say it starts with this, or it like ends with something like that. So in this case, we want to see if it starts with 519. So we'd say like, use quote, because remember the phone numbers are a string, how they're being saved in this table, they're not actually a number. Say 519, we use an asterisk, the shift 8 to say wildcard, so it's going to match 0 or more characters, and that's going to be our criteria. So it's going to say the phone number has to start with 519. So when we run this criteria, or run this query, you can see now we only have a list of patients that have 519 at the start of their phone number, and we're joining with doctor to get the doctor's name. So maybe we want to also list the patients that start with the phone number of 123. So you can see there's this or part down here. That sort of lets us add on to this criteria. So we're saying it like 519, or we could say like 123. So we're saying it either starts with 519 or it starts with 123. So we're going to list patients that start with 519 or patients that start with 123. You could run the query, and you can see that we now have both in our list. If we're interested in what that SQL looks like, we could look at the SQL view, and you can see that it's not greatly formatted, so it's just getting to this complex blob of SQL, which is again why you should always be writing this in the nice format when you're writing it by hand. So we can start making this even a little bit more complex by adding in another table. So right now we have the two tables. If we want to add more, after that little selection thing has gone away, you just right click, select show tables, and it comes back. And then we can add in more tables to sort of match this up with. So maybe we want to add in last checkup. And we want to say, let's say, make it bigger. We want to know the last checkup date too. So we just double click last checkup date. It's going to join that in. We have last checkup date. Click run. So now we also have the last checkup date for all those patients in the 519 or 123 area code with the last checkup date shown and the doctor shown. So now we are going to take a look at an example of going over sort of a many-to-many relationship using the query design tool. Remember, we have that many-to-many relationship between doctors, orders, and tests. So let's create a new query. We're going to add in doctors, we're going to add in orders, and we're going to add in tests. So remember that it doesn't actually show a many-to-many relationship here. It instead just shows the relationship entity table. So we're going to have to join across this to combine these. So let's say we want to make that list again of all of those doctors, the test they've ordered, the date that test happened, and then we want to sort it by that test date. So we start with the doctor's name. We look at the first name, last name. We're going to go with the test, and we wanted the test date, and we wanted the test name. That's called type name. So if we were to just run this, it's already doing most of the work for us. We have everything listed, all the doctors, the tests they ordered, and the time, but it's not sorted. Remember, in SQL we had to use that order by, but in here we have this nice sort box. So if we wanted to order by test date, we could pick ascending or descending, run. So now it's ordered by test date in ascending order. If instead we wanted to order it by doctor, since their name's divided into last name and first name, we could first sort by first name, ascending, and we could sort by last name, ascending, and we hit run, and you can see that it has sorted the doctors by their name. We can take a look how it's doing that in the SQL. See, first it's doing first name and then last name. If we wanted to change what order that's in, we would have to take this and move it to be the second column. Make sure it's still showing. And when we hit run, it's going to be now sorting it by the last name. This probably isn't the best example data to show that, but let's take a look at the SQL. You can see in the SQL here that it's actually now sorting by last name of the doctor and then the first name. So the order of these columns does matter in two ways. First, it's going to be the order it's shown in the result. You can see that last name's now shown first. And secondly, it's going to be the order that things are sorted in if they have a sorting set. If they don't have sorting set, like here and here, like for test date and type, then they're not going to be sorted in that order. So another thing to note is even though we show test date here, we could get rid of this, and this many-to-many thing will still work, even though we are not selecting anything from the orders table. So now that we've removed test date, it's just going to give us the list with the test name and the doctor name. That's completely fine. It's smart enough to figure out the whole many-to-many relationship for us. We got the doctors and the name of the test. So you can see how these multi-table joins become really easy in this tool. So let's take a look at another example. So one thing we might want to do is do like multiple tables joined together where we actually have that medication list for each patient, but also include in their doctor name and the date of their last checkup. So that's going to be requiring us to join 4 tables together. Remember, that was quite a complex SQL we had to write to do that example, but we can see how easy that becomes in the query designer. So we add the tables, doctor, last checkup, medication, and patient. And you can see it's already filled in all these relationships for us because we set them up earlier. We don't really have to position this in any particular way, just might make it clearer. And in this case, we want to list the medication for each patient, the patient's name, the last checkup date, and the name of their doctor. So we're going to start with patient. So we're going to say first name, drag it there, or we could double click like this. We want to say the name of their medication. So that's medication name here. I'm just going to double click. We want to say the last checkup date from this table. And we want to say the doctor's last name. So even though that there's a conflict between last name for doctor and last name for patient, we don't have to worry about that because the query tool is going to take care of it for us. So if we were to run this query, we get that list from that complex SQL example that we saw before, except it's basically doing it all the work for us. In this case, it's listing a medication for each medication that's listed for a patient. That's why we see some patients repeated. So each patient that has medication listed is going to be in this list, and they'll be in this list once for each medication. Notice that patients that have no medication listed are not included in this list. So when you join the tables, it sort of excludes people that don't have data on both sides, at least with the type of joins we'll be doing. So it looks okay. Go back to design view. If we want to tack some criteria on this, like, let's see, maybe only ones that had an SPO2 above 95. Do that here, my criteria equal or greater than 95. And if we didn't want to show the SPO2, we'd hide it, even though it's part of the criteria. We'd hit run. So these are just the medications for the patients that had SPO2, that's the oxygen saturation, of 95. And we could start making it a bit more complex. We could say their checkup date has to be, let's say they have to have had it in 2020. That's a little bit different than what we saw before. So now we're saying their checkup date has to be in the current year, 2020, and they have to have SPO2 greater than 95. And we can see it narrowed it down even more. We just have Joe Blogs and Patty O'Brien. So we can take a look just to make sure that's correct. Look at the patients. So we can see that their Joe Blogs here has a health card number ending in AB. We'll look over in the last checkup. You can see that his last checkup day was in 2020. He had, oh, sorry, that was Joe Blogs. This is him right here. He had a last checkup day in 2020, and he had an oxygen saturation above 95. To the query. Oh, that's just saying that I was on the wrong thing. There we go. Back to the query. And we'll take a look at what that looks like in the SQL view. It's using AND. So because these are in the criteria column, it's going to put them as an AND, so they both have to be true. We put them in the OR part of the criteria column, and mean this one or that one. Okay, let's go to a new example using the query design tool instead of just writing the query out. Close this. And we're going to go back to that patients table. Put that up there. So we're going to create a new query. Go to query design. We're going to select two tables, doctor and patients. In this case, we want to find how many patients a doctor has. We want to count how many patients a doctor has. So the first thing we're going to do is we are going to have to find a way to actually use the count function in here, because we don't really see any way yet. The reason why is we have it hidden right now. So to unhide it, we can click totals up here, or we can right click and show totals this way. Either one would work. I'm just going to add this new totals column. That's going to allow us to add a few functions in. So first thing we need to know is what field are we counting? And we can choose one that we know the patient will always have. It will never be null. So we can go with card num. And we change this to count. So we're saying count card num. Remember, that's not counting unique card numbers. It's counting just how many times that value occurs. So if we run this right now, it's going to say 7 because there's 7 patients. So we get 7. But we want to count how many patients exist for a certain doctor. So to do that, we'll select which doctor we want to count for by their last name. And instead of group by, we want to select expression. It's going to be applying a criteria. And the criteria in this case is going to be Smith. We want to know how many patients there are for Dr. Smith. So we can try running this, but I have something that's not quite right. So we'll see what happens when I hit run. Get this weird error that says your query does not include the specific expression, last name, blah, 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 blah. So what this is saying is that we're showing query, and we can't do that with count, at least not the way we have it set up like this. So what we can do, since we just want to count the number of patients, we don't have to show last name. We just uncheck that. Make sure we're not showing what we're just using for the criteria. The only thing we want to show is the field we're counting. We click run. We're getting a count. It says count of card num 2, and that's correct. If we were to look into the patients thing, the only time Dr. Smith shows up is for 2. That's their ID, and we can see that they have 2 patients. So we're getting the correct count. One thing we might want to change, though, is this name. It's kind of ugly, count of card num. We don't really know what that's talking about. So we'll go back to the design view. And the way we can change that is actually quite easy, although it's not quite obvious. So you go to the field, and in front of the field, you just type the name you want to rename it as. So we could type it as, let's say, patient count. And then we put a semicolon. You can even add space. So patient count, semicolon, and then the actual field name, just like that. And when we run, see, it now says patient count, and there's 2 patients. And we could make this as complex as we wanted. We could add in more tables so that we're selecting across more things. But the basic idea will remain the same. We're going to use the count. We're only going to show the count. And we can apply expressions to other fields. And we can rename the field by putting the name and a semicolon. And that doesn't just apply to counting. It also applies to any field. You could rename it if you wanted to. So one more quick example just about renaming fields. And this time we're just going to add the doctor table. And we're just going to select the doctor's last name and the scope of practice, a really simple query. And if we were to run that, we're just going to get a list of the doctor's names in the doctor table and their scope of practice. So it's basically just missing their doctor ID and their first name. Just like that. Let's say we want to rename these. We could do the same thing that we saw before. Call this like doctor. And we could call this practice. We're using the same idea with the more user-friendly name, a semicolon, or a colon rather, and then a space, and then the actual field name. And when we hit run, You can see the fields are named differently. So it's pretty straightforward. That's all I have for you in this video. Your next step should be watching my Microsoft Access Reports video. That's going to go into more depth on how to use the report tool that you may have read about in some of those readings on Microsoft Access in previous weeks. Thank you for watching, and have a great day.